Hi again, class. I'm going to talk now about how Le Chatelier's principle applies to what you'll be doing in tonight's lab. So for tonight's lab, you're going to do this virtually on the platform. You're going to take cobalt chloride and react it with hydrochloric acid. When you do that, it breaks all up into ions. And those ions in this reaction is kind of special, those ions form what we call these complexes. You don't really need to know what a complex is, but this is a metallic complex that the metal forms with water. So this is the reaction that you're going to see. It's the cobalt hydrated complex reacting with the chloride ions from the hydrochloric acid. And it is an endothermic reaction. I'm going to tell you that ahead of time because I think that will help you understand things a little bit easier. And so you're going to form a cobalt chloride complex with a -2 charge. And then water is just one of the products. So in this equilibrium reaction, you can tell your different stages of equilibrium in that if it's favoring the reactants, the solution will be pink. If it's favoring the products, the solution will be blue. And if it's right at equilibrium at that K constant value, it'll be purple. And so when your solution's purple, these concentrations will be given. And they'll be given in a little text box up to the left of the screen when you're performing the lab virtually. Okay, so that I explain a little bit more in the document, and I can help you with that as we work through it together on Tuesday night. So then there's two other parts of the lab where you're going to add an AgNO3 solution to this solution. And when you do that, you're going to release some silver ions. When you release the silver ions, those silver ions are going to react with the Cl that's in your original solution. And so what that's going to do is it's going to create this precipitate, and you're going to end up pulling Cl out of the reaction. And when you pull Cl out of the reaction, it's just like the previous video where you're decreasing one of your reactants. The stress that you're creating here is to decrease that reactant. And what's going to happen to equilibrium? And when that happens, it's going to shift it way over to the left. And so what's going to happen when you pull that chloride ion out, you shift it to the left, and your solution that results will become pink. Okay? And then the other part of the lab, you'll add a little bit extra HCl as a final step of the reaction. You add a little bit of HCl, producing more hydrogen ions and free chloride ions. So these free chloride ions in this scenario are now going to increase the amount of the chloride ion that's in your solution. If you're increasing the amount of chloride in the solution, in this scenario, your equilibrium will shift to the right and your solution will then look blue. And then the third thing that you're going to do is that you're going to change the energy. And you're going to change the thermal properties. And what you're going to do is you're going to increase and decrease the energy, and you're going to make your observations as to what happens, and then you'll explain why. But what you should see is that since it is an endothermic reaction, as you drop the temperature, so you're decreasing the heat, it's going to shift over here to make up for that deficit. And then if you increase the heat, just the opposite would happen, and it would shift over to the right. And when it shifts to the right, it's going to turn blue. I hope this is helpful.